Hello, this is the final part of the tutorial on causal graphs, and it's about CHIELD, the Causal Hypotheses in Evolutionary Linguistics database. The aim of this is to code theories in linguistics about how language evolves and how it changes, bring them together into one database to see how they link up. So for example, here's one theory from Lupyan and Dale that links the size of a population to the morphological complexity of its language. So they suggested that population size affects the proportion of adult learners in a population and the amount of contact they have with other languages. Both of these might affect the learning cost of morphology in the general population, and so languages might adapt, for example, to adult learners who are less good at learning morphology and better at learning lexical means of expression. This is their hypothesis, expressed as a causal graph. And you can imagine taking this hypothesis and then coding up many other documents that express similar relationships. If you code lots of papers, you can visualize the support that each causal link has. So some of these links will be supported by an experiment and multiple studies. Some will not be supported by so many. That already suggests a way forward. You can also, if you start doing this, you can also link theories together. So there might be theories that affect things like population size or the number of adult learners, or things that are affected by things like morphological complexity. So we can start stringing together multiple theories into larger ones. This will help us collect hypotheses and provide tools for exploring the relationships between them. So one of the things I'm doing at the UK Cognitive Linguistics Conference is to look at lots of different theories. So I think there are 21 theories here that link population size and morphological complexity. I want to look at the relationships between them and possibly do a single test that tests which one of these has the best support. CHIELD has tools that can help you do this. It also has tools that help you compare differences. For example, these are two very complicated theories about the evolution of language. You can use CHIELD to automatically find the place where they disagree. So actually it's just this one variable, this one link here. And then also use CHIELD to automatically find whether someone has tested this. In this case, it turns out that we did find a paper that none of the others were aware of that actually tested this difference and could speak to which of these theories had the best support. CHIELD is presented as a web page, so you can go now live to this page. You can search for different papers, so here's Lupyan and Dale's paper. You can get quotes for each link, like that, and see some more details about each of the links. The really cool thing for me is you can sort of mix these theories together. So here's Lupyan and Dale's theory, but we can also see how it compares to Bent's and Winter's hypothesis. And then automatically say, okay, can we discover other evidence for these particular links? And here are some other studies that have looked at similar things. For example, we can go to Mark Atkinson's study that does an experiment on this. So that's just some of the ways you might be able to use CHIELD to look up the relationships between things. Obviously, I'm interested in language evolution, but you could apply this idea to many different areas of linguistics. The code is open source and freely available. I'm very happy to help you think about how you might use it in your field. At the moment, we've got 400 documents, thousands of links and thousands of variables. This is an attempt to put all those links in one place, which doesn't really work. What's exciting for me is that about 3/4 of the hypotheses in this database are linked together somehow. So there are loads of links between things that we might not be aware of yet. And this provides an opportunity to start thinking about, okay, I know about the cognitive science of this, but are there people working in anthropology or biology or some other field that I haven't thought about? You can export stuff from Shield into things for visualization like GraphViz and Gephi, and then things for analysis like filopath or just CSV files to process in R or anything else you want. It also exports straight to Daguerty, which is a tool for figuring out the causal confounds. Shield is open source. Anyone can contribute to it. Anyone can discuss problems that there may be and edit data. So taking a paper and turning it into a causal graph is a really hard thing to do. We're not going to get it right the first time, and there are going to be disagreements. The whole process also relies on variables having the same name in order to spot that they can overlap. So this will be an iterative process of trying our best, spotting problems and editing things to bring things together. We use GitHub to support a lot of this, but there are also tools on the website. So this is just a web page where you can go and visually build the causal graph and add all the details. Click a button and then that uploads it to the Shield database. We're going to be doing some of that in the live coding. So for example, we're going to take a paper, try and sketch the causal graph, and then upload it to Shield using the coding scheme. So I'm just going to go over very quickly what the coding scheme of Shield is and what each of the fields mean. When I code a paper, this is how I do it. So I read the paper, I kind of try and get a basic understanding of the framing of what they're trying to determine. I sort of start sketching graphs. And then I read the paper again, and every causal claim that they make, every suggestion about their hypothesis, I note down, and then I use Shield to visualize that information and tidy it up, and I submit it. There are some help documents here. I'm just going to go over some basics. The format of Shield is just a very simple tabular format. So each row in the database codes a causal connection between two variables. So given this causal graph between temperature, ice cream consumption, and shirt stains, the first connection here can be represented by the first line. So I'm saying the first variable is temperature. There's a causal relation. You can have different types of causal relation. This is just a basic one. Temperature affects ice cream. There's a positive correlation between these two variables. There's some information on the topics and the type of support that they have, and then some notes to contextualize this. And you can do the same for the second causal link here on the second thing. So the idea is to take a paper, take each of these, find claims like this, and then code them up with this information. The important thing to remember is that we're coding hypotheses, not stuff that is proved to be true, which is very difficult to establish. We also want to be theory neutral, so any theory is welcome in Shield, including theories that have been disproved or theories that have been tested and found to have no support. That's useful information that we might want to discover. So how do you do this? The first thing you'll need is a free GitHub account. You don't need to understand how Git or GitHub or a command line works. You just need an account to help identify who is uploading stuff. If you have a problem, you can raise an issue. You can just go to this website and let me know what the problem is. Then you pick a document you want to code. So each sort of unit in Shield is a single document, which is usually a peer-reviewed journal article. Because I'm interested in language evolution, and I'm saying that it has to have something to do with the evolution, the theory of evolution, using that to explain some aspect of language. And that could be general theory, experiment, case studies, something like that. Usually methodologies, criticisms, and reviews are not suitable to code. You can just go back to the original sources for those. You also don't have to be an author of the document, so you can code other people's material as well as your own. Once you've got this document, you need to find the bibtech details of that so that CHIELD can understand what the source of the document is. That's easy to get from things like Google Scholar by using the little quote icon, clicking bibtech, and then you can just copy and paste this text into the field. At the moment, the idea is to code only published stuff so that we have some sort of control. Next, when you're sketching your graph, you need to choose node names. The aim is to try and reuse existing variables for CHIELD so that we can get overlaps between theories. So here's some suggestions. You can actually look for current variables that are available. Maybe what you want is already there. You should try and use a specific topic. So for example, word frequency and not frequency. So because frequency might refer to many different types of things. But you want to be general in your scope. So you want to talk about word frequency and not word frequency in Spanish, for example. A particular paper that you're coding might be talking about Spanish, but really it's kind of making a claim more generally, that you want to make that more generally searchable. It shouldn't be directional, so you should talk about temperature and not high temperature. Everything should be lowercase just to help things. And you can also use hierarchical labels. So for example, you might be talking about population size now, or you might be talking about population sizes of hominids, for example, which is a very different kind of thing. You can specify that with by putting a little colon and then specifying the type of thing. CHIELD knows that this means that these two bits have some sort of hierarchical relationship, and you can do things like visualize a graph with these things as separate, or collapse them all into a single node of just population size, and sometimes that's useful. The next field is the relationship between the two variables. So there are lots of different options here. The standard one is just the standard causal link, and most links will use this. But for example, you can say that the links co-evolve, or that there's just a correlation, or things aren't causally influenced. Something is a necessary precondition for something. This is how you code up an indicator variable. And then we have this sort of evolutionary selection pressure, which I'm probably going to phase out because it's not very useful. So note that you can do things like indicate that a correlation was tested, but the causal relationships were different. So in Lupyan and Dale's case, the causal relationships are these black arrows. But in the paper, the statistical test they actually did was looking at whether the population size predicted morphological complexity. So a correlation would be consistent with these causal things, but we can actually code it as a separate piece of information. So here we say that there's population size, it's correlated with morphological complexity, and that correlation is positive. This was determined by a statistical test, and it was confirmed. We could have also said that this wasn't confirmed, that they tested a correlation and didn't find one. Remember indicators as well. So in Lupyan and Dale's paper, they measured population contact by two variables to do with geographic spread and the number of linguistic neighbours. And you can draw that in as well. The notes section, so the quotes at the end of each row, are really important. So usually it's a quote from the paper, but you can use anything to help contextualize the causal link. So that could be a definition or a reference to the literature if they're using a reference, or a note from you, the coder. The stage variable, I'm interested in language evolution. There are various different stages for that. So for example, pre-adaptation, coevolution, cultural evolution, and language change. That just helps divide some of the theories up. You can define the type of support. So for example, something might be supported by an experiment or a review, so someone else's work, they're just citing that. a model or a simulation, a statistical test. It might be some kind of qualitative case study, logical argument, or this category hypothesis. So that means that there's no direct evidence, but there's a prediction or a suggestion. And this is really useful because if something is marked as a hypothesis, that's an indication that we might want to try and find more information, do a proper study on it to support that link. And finally, you can say whether it's confirmed or not. So by default, the assumption is that it is confirmed, but you can say that it definitely isn't. You also have the option of saying that something is predicted to have no causal relationship. So you have various options to put in negative information as well, which is also really useful. Those are useful predictions for constructing larger causal graphs. All right, so I'm going to go over all of this again in the live workshop. But the task for the live workshop will be, I'll give you a paper to read beforehand, and I'll send that list out. Then I'm going to get you to work with a group to discuss the theory of the paper and turn it into a sort of sketch of a causal graph. I'm going to do that collaboratively online. And hopefully what you'll get is a sense that using causal graphs to discuss work actually helps you understand relationships better, helps you focus your discussion on relevant bits of the work, and helps you work towards what you might need to do next to extend this work. Then I'm going to get you to upload your graph to Sheard, and when you do that, you'll get recognition that you contributed. So your name will appear on the website next to the graph. And then this graph will become part of the inventory of Sheard that can be used into the future. If you have any questions, please note them down. I'm very happy to answer them during the live tutorial. And I'll see you soon. Thank you very much.